Hello students, in this video we are going to see about Ospf protocol and how we are going to implement Ospf in Cisco Packet Tracer. The full form of Ospf is Open Shortest Path First Algorithm. It follows the Dijkstra algorithm and it is a type of interior gateway routing protocol. So we are having two types of routing protocol. One is exterior routing protocol and another one is interior gateway routing protocol. The protocols which we have seen till now like RIP V1, V2, OSPF, EAGRP all falls under interior gateway routing protocol. And particularly OSPF falls under the link state routing protocol, whereas RIP V1 and V2 falls under distance vector routing protocol. So some of the difference we can see between OSPF and RIP. In RIP, we are having the hop count limit is 15. So the routing table updates will happen within the 15 routers. Hop count is 15. And there is no hop count limit for OSPF. This is the first difference. And OSPF uses bandwidth as a metrics for choosing the best path, whereas RIP uses hop count as a best path metric. Then whenever there is a change in the network, whenever there is a change in the topology, OSPF will update it. Whereas in RIP, the updates will happen for every 30 seconds. And the OSPF supports classless routing, whereas RIP V1 does not support classless routing, it is classful routing. But RIP version 2 supports classless routing. Compared with the speed, OSPF is faster than RIP. So these are the prominent difference between OSPF and RIP. Then already we have seen EAGRP protocol. So we should know what are the difference between OSPF and EAGRP also. OSPF is an open standard protocol which is accepted by Internet Engineering Task Force, whereas EAGRP is a proprietary software which is developed and used by Cisco. Although Cisco has shared some of the working mechanism of EAGRP, it is not fully accepted by IETF, so still it remains under the proprietary version of Cisco. And before going for the implementation of OSPF, we should know there's a concept called area in OSPF. So the network is divided into logical structures called area in OSPF. Area is nothing but the collection of routers, collection of prominent nearby routers in a particular geographical area. That is called as the area. Whenever there is an update between two areas, update message to be exchanged between two areas, we are using the area border router. So each area may have multiple routers, but minimum one area border router should be there. Through ABR only it communicates, it updates its area information, updates in the area with the other area. And we'll be having many areas, and one of the area will be the backbone area. The backbone area will be connecting all the areas together. That is why it is called as a backbone area. And the backbone area is always referred as area 0. With this short introduction, we can go for the implementation of OSPF in Cisco Packet Tracer. So already, as we have seen in the EAGRP and RIP protocols, I have created the network configuration, which is very as usual, having two PCs for a network and connecting the PCs with the switch. Switch is again connected with the router and connecting the router by using the serial interface. These are the usual things. But in EAGRP and RIP, you may have noticed that I'll be using the network number here, 192.168.10.0. Like instead of using the network number, I'm using the area number. So this is the backbone area. The two routers are connected. This is the backbone area. Why it is called as a backbone area means here three networks are there. Area 0 is one network, area 1 is another network, area 2 is another network. So all these networks are connected together by using this routers, the routers in this area. This is why it is called as the backbone area, and always the notation we are using for the backbone area is area 0, area 0, area 1, area 2. Nothing but you can remember, instead of network number we are using area numbers, and area 0 should be used only for the backbone area. The other network configurations are same, like setting the IP, setting the gateway IP and everything. I think which you may refer to my previous video for this. Now let us go into the router and setting the OSPF. Okay, initially router is in this user mode. We got to go to the root mode. So type en enable, then config t. We are entering the configuration mode. Now we have to set which routing protocol the router is going to use. So router OSPF 1. Now 1 is the process ID. We may use the same process ID for all the routers. Router OSPF 1. Okay. Now we have to add the network. What are the networks connected with the router? So this network number is 192.168.10.0. So may refer. I'll show this. PC0. You can see the IPS 10.2 and PC1 IPS 10.3. So 10.2, 10.3, if I'm assigning for an PC, you may understand the network ID is 192.168.10.0. So now 10.0, we have to give the wide record mask address 0.0.0.255. Now we have to specify the area. In earlier protocols, RIP and EAGRP, we won't be specifying the area, but here we have to specify the area. So this network 192.168.10.0 is area 1. I'm writing area 1. Okay. And this router is having one more area. This area 0, which is a backbone area. So the number I have used is 192.168.30.0. That is the network address. And I have assigned the router 1 and 2. The numbers are 192.168.30.1 for router 0 and 30.2 for router 2, which is the same architecture which I have used for my EAGRP protocol. So 255. Now what is the area? You may see. What is the area? Area 0. So we got to specify area 0. Okay, now the configuration settings is over in router 0. Now we may go for router 1. So go to the root mode, en, then config t. Now what I got to do? I have to specify the what routing protocol we are going to use. Router OSPF. Did you remember the process ID? Yes, we have given the process ID 1. So router OSPF 1. Now we have to add the network. So this network number is 20.0. So you may see 20.2 I have given for PC2. 20.3 I have given for PC3. So 20.0 is a network ID. So network, sorry, this is router 0. We got to go for router 1. So 192.168.20.0. And what is the wildcard mask address 0.0.0.255? And what is the area? Area is 2. This belongs to area 2. So we got to specify this area. Area 2. Another address, backbone area, we know 192.168.30.0.0.0.255, area 0. So now we have set the network configurations in both the router 0 and router 1. Now we may use a ping command to check whether the packet transmission happens using OSPF protocol. So let me take PC3. The PC3 IP is 192.168.20.3. To this PC3, I'm going to send a message from PC0. Okay, go to command prompt, ping 192.168.20.3. Yes, I'm receiving the response message from 20.3. That means the packet communication happens using OSPF protocol. And this is example for OSPF multi-area network. The only difference between OSPF multi-area and single area is here I have specified 3 areas, area 0, area 1 and area 2. In single area network, all the 3 networks we can assume to be in area 0. So instead of giving area 1 and area 2 along when you are adding the network, we can give the same area 0. So that is the OSPF single area network. Thank you.